Hello learners of National Institute of Open Schooling, you are all welcome to the studios of National Institute of Open Schooling. In this program on mathematics, we are today going to talk about the quadratic equations. A quadratic equation, what do we mean by a quadratic equation? We show you a general example, ax square plus bx plus c is equal to 0. Now, look at this. This equation is formed by a polynomial ax square plus bx plus c, which is a second degree polynomial. In this, a, b, c are real numbers or they can be even complex numbers, and x is a variable, but the condition and the strict condition is a can never be 0, because the moment a becomes 0, this ceases to be a quadratic equation. So, a quadratic equation we see is a polynomial equation of second degree in single variable. Our today's program is as to how to solve this equation. What do we mean by solving this equation? By solving an equation, we mean finding value or values of x by which the left hand side, that is ax square plus bx plus c, becomes 0. This can be done by 4 different methods: factorizing, completing the squares, using quadratic formula, or graphing. And for this, at times we have to write the equation in the simplified form, that is ax square plus bx plus c is equal to 0 is rewritten as x square plus b over ax plus c over a is equal to 0. That is, we have divided the whole equation by a, because a is not equal to 0. So, we can always divide by a number which is not 0. So, simplified form of this equation can be written as x square plus bx. Now, these values of x which make the left hand side 0, they are called the roots of the quadratic equation. Now, remember, quadratic, degree being 2, there have got to be 2 roots. If the degree of the equation is 3, there will be 3 roots, and so on. Now, these roots can be different, they can be repeated roots. For example, in case I have a quadratic equation x square is equal to 4, then x can be 2, x can be negative 2. So, there will be 2 roots whenever the power or the degree of the equation or the polynomial is 2. Let us take an example. I consider x square minus 5x minus 6 is equal to 0. I give value negative 1 to x. What happens? I get negative 1 square minus 5 into negative 1, negative 6, that is on the left hand side, which on simplification gives me 0. So, what did I tell you? That whenever the left hand side becomes 0 for some value of x, that will be the root of the equation. So, negative 1 is a root of this quadratic equation. So, we try another value. So, this time in place of x I take 6. I get 6 square minus 5 into 6 minus 6, which on simplification gives me 36 minus 30 minus 6, which is again equal to 0. So, because 6 has also made it 0, that means 6 is also a root of this equation. So, talking of the equation as a whole, x square minus 5x minus 6 is equal to 0. This has got 2 roots, negative 1 and 6. Now, going back to the equation once again, x square minus 5x minus 6 is equal to 0 can be written as x plus 1 into x minus 6 is equal to 0. Now, whenever the product of 2 factors is 0, you must recall that either both the factors are 0 or at least one of them is 0. So, if x plus 1 is 0, you will get x is equal to negative 1, and if x minus 6 is equal to 0, you will get x is equal to 6. So, that means we have indirectly solved this equation by the method of factorization. We use the method of factorization to arrive at the roots of this equation x square minus 5x minus 6 is equal to 0. We consider yet another equation. This time the equation that I am considering is 4x square minus 4x minus 3 is equal to 0. Now, we want to solve this equation by factorization. To factorize, we have to split the middle term in relation to the first and the third term, so that we are getting two factors. So, I write down 4x square minus 6x plus 2x minus 3 is equal to 0. Remember, minus 6x plus 2x will give me minus 4x. So, I have not changed the equation, I have simply rewritten it for a convenient operation. This gives me 2x common in the first two terms, where I get 2x into 2x minus 3 plus 1 into 2x minus 3. So, in the two groups I get 2x minus 3 as a common factor, which gives me 2x plus 1 into 2x minus 3 is equal to 0. Now, remember once again, whenever two factors when multiplied together give me 0, then at least one of them has got to be 0. So, here 2x plus 1 is equal to 0 or 2x minus 3 is equal to 0. 2x plus 1 is equal to 0 means x is equal to negative 1 by 2, and 2x minus 3 is equal to 0 gives me x is equal to 3 by 2. This means negative 1 by 2 and 3 by 2 are the roots of the equation 4x square minus 4x minus 3 is equal to 0. Now, let us go back to the general form of the quadratic equation. Ax square plus bx plus c is equal to 0. Just now, a little while back, we solved two equations by factorizing. Can we factorize this and solve it? Let us try to see what happens in case we take c to the other side, but then factorization is going to involve operation with a, b and c. Recall the factorization that you have done in your earlier class. Whenever the x square has got a factor or has got a coefficient, whenever ax square plus bx plus c is such that x square has got a coefficient a and the constant term is c, we multiply these two and thereby I get ac. Now, to split the middle term, what I have to do is to find two factors of ac, means two numbers when multiplied together give me ac, whose sum is equal to b, but that is not the only situation. C can be having a negative sign before it. If C is having a negative sign before it, then earlier process will be the same, means A C will have to be multiplied and we get A C. Now, this time two factors of A C have got to be such that their difference, mind, because C is preceded with negative sign. So, two factors of A C whose difference is B. That is how we will break it up to get the splitting the middle term. Let us work on the equation a x square plus b x plus c is equal to 0. Shifting c to the right hand side, I get a x square plus b x is equal to negative c. I divide the whole equation by a. Remember, a is not equal to 0. A quadratic equation will cease to be a quadratic equation the moment the coefficient of x square is 0. So, I get x square plus b over a x is equal to negative c over a. Now, I want to complete the square on the left hand side. I take half the coefficient of x in the equation x square plus b over a x. Half the coefficient of x will be b over 2a. So, I get b over 2a square I add on the left hand side and b over 2a square I add on the right hand side, which gives me on the left hand side x plus b over 2a whole square, and on the right hand side I get b square minus 4ac over 4a square. So, I get a relation between the term of x equated to a constant. Remember, a, b, c are all constants. If I take the square root, I will get x plus b over 2a is equal to plus minus under root b square minus 4ac over 2a, plus minus because square root of any quantity is always written as plus minus unless otherwise instructed. Here, because we are talking about of all the roots, so talking about all the roots, we have to take plus as well as minus. If I shift b over 2a to the right hand side, I get x equal to negative b plus minus square root of b square minus 4ac over 2a. Mind you, these are the two values of x, which are minus b plus under root b square minus 4ac over 2a, and the other value is minus b minus under root b square minus 4ac. I completed the square on the left hand side by one method. I intend showing you another different method by which the square can be obtained faster. We consider the equation once again. Equation is ax square plus bx plus c is equal to 0. Shifting c to the right hand side, I get ax square plus bx is equal to negative c. Now, instead of dividing by a and then adding the square of half the coefficient of x, what I do this time is multiply the whole equation with 4a. I get 4a square x square plus 4abx is equal to negative 4ac. What have I multiplied with? 4 times the coefficient of x square. That means 4a is the number by which I multiplied the whole equation. Next, I add b square to both sides. Where does b come from? B is the coefficient of x. So, the square of the coefficient of x I add to both sides. I get 4a square x square plus 4abx plus b square is equal to b square minus 4ac. Look at the right hand side, this is b square minus 4ac, all constants. On the left hand side, if you look carefully, this is the square of 2ax plus b whole square, which is equal to b square minus 4ac. Taking square root, remember, if you take square root, you will have to put the plus minus sign. So, I get 2ax plus b is equal to plus minus under root of b square minus 4ac. Shifting b to the right hand side and dividing by 2a, I get x as the same value which I got by the other method. So, we can utilize this method to find the root of the or the roots of the equation faster. This is as far we go in this program. We will be in the second program these quadratic equations. In the meantime, please go back to your study material and compare whatever you are learning you have done now and whatever learning is required. Work on that, and in case of any problem, you get back to us on the phone number shown on your screen, or better still, email us and we will get back to you. Thank you very much. Hello learners of National Institute of Open Schooling, you are all welcome to the studios of National Institute of Open Schooling. In this program on mathematics, we are today going to talk about the quadratic equations. Take the case of this equation, 5x square plus 8x minus 4 is equal to 0. First step, shifting c to the right hand side, instead of c I am having minus 4. So, shifting to the right hand side, I will get 4, I get 5x square plus 8x is equal to 4. I multiply with 4a, a here is 5. So, I multiply with 20. So, multiplying with 20 I get 100 x square plus 160 x is equal to 80. Then what did I do next? In the process, I advise you to add the square of the coefficient of x. Coefficient of x is 8, the square of 8 is 64. So, 64 I add to the left and I add to the right. So, I get 100 x square plus 160 x plus 64 is equal to 64 plus 80. The left hand side becomes the square of 10 x plus 8 whole square, which is equal to 144. Square root gives me 10 x plus 8 is equal to plus minus 12. Square root of 144 is 12. So, because we are taking square root, so I take the positive and negative sign both. Shifting 8 to the right hand side, then dividing by 10, I get x is equal to negative 2 or 2 by 5. What are these negative 2 and 2 by 5? These are the roots of the equation 5 x square plus 8 x minus 4 is equal to 0. So, this is another way of completing the squares and arriving at the result. What result? Finding the square of the roots of the equation. So, repeat again, a x square plus b x plus c is equal to 0 will give me value of x is equal to negative b plus under root of b square minus 4 a c over 2 a and minus b minus under root of b square minus 4 a c over 2 a. Now, in this case, this b square minus 4 a c is a very important term. We call it the discriminant. Why the discriminant? This is going to discriminate between the kind of roots that we are going to get. Let us go back and look at the value of x. If b square minus 4 ac is positive, positive means I will get some square root because it is a real number. That means I will get two distinct values of b square minus 4 ac under root. So, what kind of roots will I be getting? In case b square minus 4 ac is positive, means greater than 0, then the roots will be real and they will be distinct. But in case b square minus 4 ac is equal to 0, what will happen? Look at the value of x once again. It will be x will be equal to negative b over 2 a, and once again the second root will also be negative b over 2 a, means I get real roots, but the roots are equal, they are repeated roots. Still we say there are two roots, whether they are the same or they are distinct, but they are same means they are repeated roots. What happens in case b square minus 4 ac is less than 0, means it is negative. Recall the lesson on complex numbers. Square root of negative numbers gives us imaginary numbers, and plus minus some real number or complex number gives us the complex number. So, we say in this case the roots are going to be complex, and complex roots, because in one value of x it is negative, in the second value of x it is positive. So, we get the complex roots as a conjugate pair. Now, going back to the equation once again, we are going to this time talk about the relation between the roots of the equation and the coefficients of the terms, various terms of the equation. A x square plus b x plus c is equal to 0. This gives me the two roots negative b plus under root b square minus 4 a c over 2 a and negative b minus under root of b square minus 4 a c over 2 a. I call one root as alpha and the other root as beta. It does not matter which you call alpha or beta, but for convenience I have called the first one as alpha and the second one as beta. What will happen in case I add alpha and beta? Alpha plus beta gives me negative b plus under root b square minus 4 a c minus b minus under root of b square minus 4 a c over 2 a, which gives me negative b over a. What is b? B is coefficient of x. What is a? Coefficient of x square. So, the sum of the roots is negative the coefficient of x divided by the coefficient of x square. So, this is what the sum of the roots of the equation gives. Let us talk about the product of the roots. We multiply alpha and beta. When we multiply alpha and beta, we get negative b plus under root of b square minus 4ac into negative b negative under root of b square minus 4ac over 2a into 2a will be 4a square. Simplifying, I get c over a. Remember, c is the constant term in the quadratic equation, a is the coefficient of x square. So, the product of the roots is the constant term divided by the coefficient of x square, a very important result. The sum of the roots negative the coefficient of x divided by the coefficient of x square, product of the roots the constant term divided by the coefficient of x square. Now, we take a situation, I say alpha beta are the roots of a quadratic equation, this is given to us. We want to form a quadratic equation with these roots, very simple, alpha and beta were obtained by factorization. So, the quadratic equation is going to be x minus alpha into x minus beta is equal to 0, when simplified gives you x square minus alpha plus beta x plus alpha beta is equal to 0. Alpha plus beta is the sum of the roots and alpha beta is the product of the roots. So, this is hinting at another very convenient way of writing the quadratic equation when the roots are given. Roots are given, find the sum, find the product and write down x square minus the sum of the roots into x plus the product of roots. So, we apply this to another situation. Alpha beta are the roots of the equation 5x square minus 6x plus 3 is equal to 0. We want to form an equation, a quadratic equation whose roots are alpha cube and beta cube. Remember, alpha and beta are the roots of the equation which is given to us. We are required to find out an equation or write an equation, quadratic equation at that, whose roots are of alpha cube and beta cube. So, what do I have to do? I have to find out what is alpha cube into beta cube is. Alpha cube plus beta cube will be the sum of the roots and alpha cube beta cube will be the product of the roots, and I will straight away write down the equation x square minus the result of alpha cube plus beta cube plus alpha cube beta cube, that is the product, and write it equal to 0. So, this is how we proceed. If alpha beta are the roots of the equation this, then alpha plus beta is 6 over 5 minus the coefficient of x divided by the coefficient of x square. Alpha beta is 3 by 5, constant term divided by the coefficient of x square. We are trying to find out alpha cube plus beta cube. Alpha cube plus beta cube, by the identity we get alpha plus beta into alpha square minus alpha beta plus beta square. Alpha plus beta into alpha plus beta whole square minus 3 alpha beta. I readjust this because the values known to me are only alpha plus beta and alpha beta. So, alpha square plus beta square is not known to me. So, I change this term in the bigger bracket to bring in alpha plus beta and alpha beta, and using these values of alpha plus beta and alpha beta, I write down that alpha cube plus beta cube is negative 54 by 125. What next we have to find out? Yes, alpha cube beta cube. So, alpha cube into beta cube will be alpha beta whole cube, which is equal to 3 by 5 whole cube, which is 27 over 125. We are now ready to write the quadratic equation. What is the quadratic equation? X square minus the sum of the roots. Sum of the roots is negative 54 by 125. So, it will be 54 by 125 x plus the product of roots. What is the product of roots? 27 over 125. Multiplying the whole equation with 125, I get the required quadratic equation as 125 x square plus 54 x plus 27 is equal to 0. This is how we can form a quadratic equation when the roots are known. Now, I take you to another situation. We take another quadratic equation, x square minus 6x plus 10 is equal to 0. Now, in case you try to break the middle term, you might be having some problem, because two factors of 10 whose sum is 6 is difficult to find out. So, we use the relation that we obtained. What relation we obtained? Given a quadratic equation a x square plus b x plus c is equal to 0, then x is equal to minus b plus minus under root of b square minus a 4 ac divided by 2a. Recall, little while back we did that. So, using that discriminant method, we write down x is equal to 6, minus b means 6, plus minus under root of 36 minus 40 divided by 2. Now, under the square root sign, I get negative 4. Negative 4 means 2 iota. So, I get negative 6 plus minus 2 iota divided by 2, which is negative 3 plus minus iota. I am getting two roots. One is negative 3 plus iota, the other is negative 3 minus iota. Both are complex roots. And what kind of these complex roots are? In case you look at these roots, these are a conjugate pair. Another example, x square plus 4x plus 13 is equal to 0. Once again, factorization may not be possible, but yes, minus b plus minus under root of b square minus 4 ac divided by 2a is possible. We use that relation and find out that x is equal to negative 4 plus minus 6 iota, and ultimate the results are the two roots that we get of this equation are negative 2 plus minus 3 iota, again a conjugate pair. So, we arrive at a very important result that complex roots of any quadratic equation occur in conjugate pairs. So, if at any time you are given a complex number as one of the roots of a quadratic equation, then the second root is automatically known. If a plus b iota is a root of an equation, then a minus b iota has got to be the root of that quadratic equation, because complex numbers or complex roots occur in conjugate pairs. This is as far we go in this program. We have given you the method of factorization, substitution, we have given you the method of completing the squares, we have given you the idea that complex roots occur in conjugate pairs. We will be in the second program these quadratic equations go on to give you further idea as to how to play with these quadratic equations, and in particular when the quadratic equation is not simply x square. Supposing an equation is a x 4 plus b x square plus c is equal to 0. So, we will be getting the value of x square and not x. So, how to go about solving such equations? This is what we will be taking up in our next program. In the meantime, please go back to your study material and compare whatever you are learning you have done now and whatever learning is required, work on that, and in case of any problem you get back to us on the phone number shown on your screen, or better still email us and we will get back to you. Thank you very much.